Okay, so continue on with chapter 1. Our next one is significant figures and measurement accuracy. Our topics are computing pharmacy calculations or retaining accuracy at the correct number of significant figures is our learning objective for this section. Significant figures and measurement accuracy. Rounding and estimating have been discussed as a practical way of using numbers to calculate and measure a dose. In the process, you should not lose sight of the mathematical principle that each numerical value has a certain number of significant figures. These significant figures consist of those that are known to be accurate plus the digits in the lowest place value, which is approximate. The lowest known place value is the last digit on the right of a written numeral. You will most likely use more significant figures when you're doing mathematical problems with calculating weight of a medication, basically when you're compounding a medication from scratch, combining the powders, the what are they called? Soluble, like creams, let's see, lotions, emulsions, that extra stuff that you're gonna use, and you're gonna weigh both the powder and the solute and mix those together basically when you're doing some type of compounding. And significant figures play an important role when you're measuring these medications for compounding. Okay, so let's move forward. Significant figures are digits that have a practical meaning or a value. A leading zero that marks the place of a decimal is not significant because it only marks the place value of the number that follows that decimal. So it's only a place value, so it's not a significant digit. Counting a significant figures begins at the first non-zero digits. So here are some rules. The first rule is begin counting at the first non-zero digit. Second rule is counting to the right until you reach the value that is in the last or rounded. Zeros that are located between digits are significant, should be counted. So by digit, it means the actual number. So 403, the 0 would be considered significant because it's between the 4 and the 3. So those are digits. Do not count zeros that are placed to the left of the first digit. They are only marked the place value of the decimal. One or more final zeros may or may not be significant depending on the accuracy to which the number is held. So depending on to the actual, so say 100. So it's 100. You would think it had 3 significant figures, correct? Because of course the first non-zero value is the 1, and then you have 2 consecutive zeros after that. So depending again on the significant of the accuracy, so if the accuracy of that number is to the exact value, those values would all be significant. But if it's been considered an estimate value, the last zero is not significant, therefore it would only have 2 significant figures, and that last value would be an estimate. So large numbers have significant figures based on their accuracy to the nearest factor of 10. Okay. If a very large number of substance is measured, at some point the person doing the measurement must estimate the closest amount represented by the device being used. So like we were talking about weighing measurements, scales, for example. Some of those scales are either accurate to the 10th place or the 100th place. So in that sense, if you have any more digits more than the 10th place, they're not considered significant anymore, or the 100th place. As a result, the last digit recorded cannot be considered to be accurate and thus is not significant. Okay. So here are the examples of significant figures, how many significant figures there are. So 1.8, they're all digits, so they're all considered significant, so that'll be 2. 8.3, again, all digits, so 3 are significant. 138, all 3 of them are significant. 1.832 has 4 significant, and so forth. For example now, this zero is used as a place value, placeholder. And then, so the 1 digit would be our first significant figure, so that's why there's only 3 here. And then again, for the next one, 0.01, these two first zeros are not considered significant, because remember, it will be, according to the first one, first numerical number, it'll be considered significant. So the 1 is the only significant figure. 0.8, again, the 0 before the point is only considered a place value, therefore the 8, so there's only 1 significant figure. And 8 by itself is, of course, 1 significant figure. So here's an example. An item is weighed on a balance with a degree of accuracy to the nearest tenth place when measuring milligrams. The balance indicates that the item weighs 1.459 milligrams. How many significant figures does this weight have? What would the rounded value be? So again, we said that this weight has a significant figure to the 10th place. So anything after the 10th place is not considered significant. Therefore, it only has 2 values that are significant, 1.4. But of course, the 5 next to it, so we need to round off, right? Because it's only accurate to the 10th place, which is the 4. So looking at the value after the 4, it's 5. 5 or greater, that means we have to round that 4 to 5. So our actual value is 1.5 milligrams. That's how much our medication would be considered to be weighing. Because again, the scale is only accurate to the 10th place. Anything after would not be considered significant. Even though our rules, remember, state that any digit is significant, so you would think that there would be 4 significant values. But remember, according to the last rule, is that depending on the item that we're measuring, and in this case, the scale is only significant or only accurate to the 10th value. That way, that's the reason why we only have 2 significant figures in this problem. I hope you understand that. This is the end to section 1.5. If you guys have any questions, again, there's the Q&A discussion board. Place a question there or a comment there if you need more clarification. Maybe other fellow students can help you out, or myself. Or if you just want to send me a private message, again, there's the email, and I can go ahead and discuss this further with you. See you in the last section in the next video.